Okay, a regular pentagon is inscribed inside a circle. The circle has a radius of 8 units. What is the measure of the central angle of the pentagon? What is the approximate measure of the apothem of the pentagon, rounded to the nearest hundredth? Using your answers to the previous questions, what is the approximate measure of the perimeter of the pentagon, rounded to the nearest hundredth? And then using your answers to the previous questions, what is the approximate area of the pentagon, rounded to the nearest whole number? Okay, so this one is different because it's not the area of the octagon, it's a pentagon. It's very similar though because we have a regular pentagon inscribed in a circle. So we have this circle, and a pentagon has 5 sides. So 1, 2, 3, 4, and 5. So it will have 5 vertexes, and just putting them on the circle helps me draw it a little bit better. So we have this pentagon. We know that it says the circle has a radius of 8 units. So from the center of the circle to one of these vertexes, or to any point on the circle, is 8. Now, the easiest way to draw triangles within this pentagon would be not straight through it. It would be from the center to the vertex point, because the vertex point is also on the circle. So that also meets the requirement of the radius. So if we were to draw that out, notice that we have all of these triangles that have 2 side lengths that are 8. Again, that means that these base angles right here will all be the same angle because they're opposite sides. Right here, this side length is 8 and it's opposite that, and then this one is also opposite a side length that is 8 as well. So that's why these base angles are all going to be the same, is because they're opposite sides that are all the same length. So again, very similar to how we found the angles in the triangle from the last one. So now it says, what is the measure of the central angle of a pentagon? Well, in a pentagon, there's 1, 2, 3, 4, 5 angles that are splitting up that central angle. So I'm going to take 360 and divide it by 5, and it gives me this angle of 72 degrees. So this angle right here is 72 degrees. So with that, I'm looking for A of 72 degrees right there. So now, what is the approximate measure of the apothem of the pentagon? Again, we're trying to find this height from the center straight down to this midpoint. So it cuts this length and this length in half. We have that as a 90-degree angle, and we are wanting this to be H. So we know that these 2 angles in the triangle, we've got to find these base angles. So again, to find that base angle, I know in a triangle there's 180 degrees. The central angle of this is already 72 degrees right there. So I'm going to subtract that 72 degrees that I know. That leaves me 108 for both of these angles because they're the same. I'm going to divide it by 2. So that gives me 54 degrees. So I know each of these angles is 54 degrees. So that means this angle would be 54 degrees right here, and this angle would be 54 degrees right there. So now I'm going to just draw this triangle right here, open, and sorry, I'm going to draw this triangle a little bit bigger so we can see it better. So we have it coming from the center down to the base, over, and up. And again, I don't know what this length is, so I'm not going to put anything there, but we do know that this angle is 54 degrees. Again, right here, it's that base angle, and we know that by, because all of these angles are the same by the base angle theorem. We are looking for our h, and we do know that the radius is 8. So we have a right triangle. We're solving for one of the side lengths. I don't have two side lengths, so I'm not going to use the Pythagorean theorem, so I'm looking for my trig functions, and I'm going through my mnemonic device, SOHCAHTOA, and I'm going to be labeling it or looking at this triangle based on our angle that was given. So the side length opposite it, which would be h, which would be labeled the opposite. Side length across from the 90 would be the hypotenuse, and the side length touching the angle but not the hypotenuse is the adjacent side length. So now I'm going, okay, well, I want the opposite side length and I have the hypotenuse. So sine is the opposite and hypotenuse. Alright, it has both of those side lengths in it, so that's the one I'm going to be using. So we have sine of 54 degrees is equal to h over 8, the opposite divided by the hypotenuse. So h is being divided by 8. Again, we're going to use the inverse operation. Multiply both sides by 8, because I know this will reduce down to a 1. So then I'll have 8 sine of 54 is equal to 1h, because 8 divided by 8 reduces down to a 1, and this is more typically just written as 1. It's implied, as h, it's implied that the 1 is there. So if we jump over, we have 8 sine of 54 degrees. So that gives us 6.472, and it is wanting us to round to the nearest hundredth. So this 2 would keep that 7 as a 7 since it's not greater than 5. So 6.47 units for B. 6.47 units right there. Okay, and so now using your answers to the previous questions, what is the approximate measure of the perimeter of the pentagon? So now they want us to find this adjacent side length, because if we can find this side length right here in our triangle, again remember that it's half of our total base, so then I would have half, and then I could double it to find that full length, and then I know what each of these side lengths would be. So that's my game plan. So I'm going to find this side length right here, and it wants us to use the answers from our previous questions. So now I know that this opposite is 6.47. Yep, 6.47. 6.47 units. So now it's a right triangle, and we do have two of the side lengths, so I can set it up using the Pythagorean theorem. Again, remember the Pythagorean theorem is a squared plus b squared is equal to c squared, where c is the hypotenuse. So this h, since that's our hypotenuse, is c. The a and b don't matter, so I can label this as b and just solve for b. So then I'm going to substitute in the values for a and c. A was 6.47 squared and c was 8. So I'm going to type that into my symbol lab. We have 6.47 being squared plus our b being squared is equal to our 8 being squared. And this will write it out a lot easier. So it says subtract 6.47 squared from both sides. So that's how they went. 6.47 squared minus 6.47 squared is 0. So that's how they went from here to here with just it being b squared on the left hand side. And then 8 squared minus 6.47 squared, they typed it in. They got 22.139, and then because that's being squared, we would square root 22.139, so we have the positive and the negative of that square root. Since we're dealing with a length, we want the positive version, and that decimal is 4.7, and it wants it rounded to the nearest hundred. So we're gonna just keep this as 4.705. So that when we do it, there won't be as many rounding errors. 4.705. Okay, so now again, remember I had said that that would just be our half of our base. So this is 4.705. So I'm going to multiply it by 2 so I can find this total length right here. And I'm going to draw that in a different color so we can find that total length of the base. So 4.705 multiplied by 2 is going to give us 9.41 as our base right here. So this whole side length right here is 9.41. So that means this side length right here is also 9.41. And so when we're finding perimeter, again, we're going all the way around the outside. So there is 1, 2, 3, 4, 5 identical bases on the outside of this pentagon. So I'm going to take 9.41 and multiply it by 5 to find that perimeter, because there's 5 congruent sides. So this comes out to be 47.05. And I'm looking for the value of C, because that's our answer for C, 47.05. And I am seeing 47.1 units, so that's our closest option. So again, there was just a few rounding errors that made the difference. So it is 47.1 units squared. And then it says, using your answer to the previous questions, what is the approximate area of the pentagon? So again, we're going to use our base times our height. Again, our base was 9.41. We're going to use the area of this triangle. Sorry, let me back up and explain what I'm thinking. So we're going to use the area of one of these triangles, and then we're going to multiply it by 5 because there's 1, 2, 3, 4, 5 identical of those triangles. So again, remember the base was 9.41, and we found out earlier that the height was 6.47. So that's 6.47. So we're going to do 1/2 times our base, which is 9.41, times our height, which is 6.47, and that is going to give us 30.44, and that is just for one of those triangles. So I'm going to type in 30.44135. I'm pulling it from right here, the answer to our last question, and I'm multiplying it by 5 because we have 5 of those identical triangles. So this comes out to be 152.2, and it's wanting it rounded to the nearest whole number, so this will be 152 units squared. So that's how I would answer this question. It's very similar to the previous one, just that it has the regular pentagon instead.